Next, we move on to customer-side software monitoring, which is typically implemented through automated crash, failure, or defect data reporting mechanisms. Customer or client-side software monitoring is important, but differs significantly from server-side monitoring. Unlike server-side monitoring, which is continuous and controlled, customer-side monitoring is typically event-driven. It is implemented using tools that automatically send error reports or prompt users to submit reports containing core dumps and configuration data. While logs and metrics are heavily relied upon in server-side monitoring, they may not be included in customer-side monitoring reports. Despite the growing dominance of web-based applications, fat clients, software installed directly on devices, continue to persist, particularly in environments with limited or no network connectivity. However, monitoring on the customer side comes with limitations. It's not fully under the software provider's control. Privacy concerns, legal restrictions, and network limitations can affect what data can be collected automatically. In severe cases when critical problems arise, customers are often motivated to share logs and other relevant data to expedite problem resolution. Defect reporting is essential for improving software, but traditional methods, like lengthy forms, can create significant barriers. Take this example: 12 fields to fill just to report a single bug. How many people enjoy filling out forms like this? Is it appealing or quick? The reality is these forms can discourage users from reporting defects, delaying crucial feedback. To reduce effort and enhance the collection of defect information from real-world use, smarter and more automated solutions are required. Why is automatic defect reporting so important? First, it ensures we're fixing the right defects. Software's value is created during real-world use, so prioritizing bugs that frequently occur in actual usage should be a top priority. Second, support calls or emails cost money. Have you ever found the support number for Google or Microsoft? Me neither. However, I have used their automated defect reporting tools. Lastly, defect information passed through manual reporting can resemble a game of Chinese whispers. By the time the defect reaches developers, crucial details may be lost or distorted. Automatic reporting captures accurate, detailed data directly from the source, eliminating this issue. Reliability in defect reporting can be a major challenge. The quality of defect information often varies between reporters. As we see here, different testers report the same defect in inconsistent ways. Tester 1 provides detailed and accurate information, the module, version, and description. Tester 2 gives vague details, like current version, making it harder to reproduce the issue. Tester 3 gives report that is incomplete or uses shorthand, leading to potential confusion. This variability affects the reliability of the defect database, making it harder for developers to act on the reports. Standardized automated reporting can address this inconsistency, ensuring accurate and uniform defect data is collected every time. Let's take another example. What's wrong with this figure? At first glance, it's clear the defect is identified. A bug, represented here by the grasshopper, enters the system. However, the issue lies in how this information flows. The defect information is processed by a human who manually inputs the necessary details into the defect reporting database. This manual process is tedious and prone to errors. Ideally, we aim for the majority of defect information to flow automatically, as illustrated in the updated figure. In this setup, humans provide only minimal input, while most of the bug-related details are automatically pushed to the defect database. This automation streamlines the process, saving time and reducing errors caused by manual defect reporting. This table highlights the usefulness of different types of bug information based on research data. It provides insight into what developers find most valuable when diagnosing and fixing defects. Some observations follow. 1. Steps to reproduce stand out as the most useful, with 97% of respondents rating it as essential. 2. Screenshots follow closely, being highly valued for providing visual context, with 50% finding them very useful. 3. Part of the application. Knowing exactly where the issue occurs was rated very useful by 66%. 4. Operating data, like logs and runtime metrics, also ranks high, with 48% finding it very useful. This table illustrates the frequency of missing or incorrect information in defect reports. It sheds light on common gaps that can hinder the defect resolution process. Key observations include: 1. Configuration of the application is frequently cited as incomplete, with 38% of respondents saying this occurs quite often, and 21% noting it happens every often or always. 2. Software context and hardware context are also problematic, with over half of respondents indicating quite frequent inaccuracies or missing data. 3. User input and screenshots behavior are commonly incomplete, with 57% and 50% of respondents respectively stating these issues arise quite often or very often. 4. Even steps to reproduce, widely considered essential, are reported as quite often missing or incorrect by 54% of respondents. Finally, automated client-side monitoring enables 24/7, 365 quality tracking. This provides continuous insights into software stability across its lifecycle. This graph showcases crash data for the Firefox browser measured as crashes per active daily user, blue line pre-beta builds. Higher crash rates are observed during early development stages, reflecting ongoing debugging and feature integration. Red line, beta builds. Crash rates drop significantly as the software stabilizes through testing, but occasional issues still arise. Green line, stable release. Representing the most refined version, crash rates are at their lowest, reflecting robust testing and optimization efforts. Such tracking systems allow teams to quickly identify issues in new builds and to monitor trends over time to ensure ongoing stability. To conclude, automatic defect reporting offers several key benefits. First, reduced effort in defect reporting. Automated systems eliminate the need for users to manually fill out lengthy forms, making defect reporting more efficient and user-friendly. Second, increased reliability of defect reports. Automation ensures that the information captured is accurate and consistent, reducing human error and variability. Third, improved prioritization and efficiency in bug fixing. By providing structured and comprehensive data, automated reporting allows developers to focus on the most critical issues, improving response times and overall software quality. Fourth, 24/7, 365 quality tracking. Automated systems continuously monitor and report on software performance, including client-side issues, enabling proactive identification and resolution of defects before they escalate.